I received a fairly simple question here to answer. Well, there's a statement in here, enter on open and exit on bar close. That's not the question. The question is right here. Question, how to only allow for 2 bars in a row max. So only allow for 2 bars in a row max. So as we can see here, right, if we get 3 bars in a row, then we want to, eliminate the 3rd bar. If we get 3 bars in a row, and so on and so forth. So if there's 4 bars in a row, then we only want to allow the first 2 signals to get through and block any remaining signals. All right. So that's our first question there. I'm going to switch over to the logic tab. So let's see, we're going to hit the new button to create a new logic template, right? Let's see, what should we call this? All right, so only 2 bars in a row. So kind of looking at this screenshot here that was sent in, it looks like Randy's just using the bar direction solver. And so, right, there's some consistency here. So as soon as we get 3 up bars in a row, right, so here's 1, 2, 3rd up bar, we start getting signals. 1, 2, 3rd up bar signals. And my guess on these down bars here, probably the same, 1, 2, and then 3rd down bar. We're getting signals here. So that makes a simple way to kind of make some signals to work with. So I'm just going to take the bar direction solver, and this will be my signal source here to work with. And I'll connect that in. And all right, there we go. So there we have it. If we get a bunch of down bars in a row, then right, we're going to get at least 3. Sorry, I didn't finish setting up the solver. There we go. We want number of bars 3. There we go. All right, so now we have something similar to that screenshot. So now we just want to start blocking all the signals after the first 2. All right, so there we go. So we'll block the signals that have the diamonds on them. So there's 2 ways we can do this. One way is I could use the signal blocker. That's a little convoluted. I think the most understandable way would be to use the signal counter, and this is the most universal way as well, to use the signal counter. So we're going to connect this up here, right? And as the name implies, we're going to count signals, right? And so once we get to our 3rd signal, so we're using the signal counter in kind of an opposite fashion, in kind of a backwards fashion. So what we're going to do is we're going to count to the 3rd signal here. And so if we get a 3rd signal, then at that point we're going to use the third signal to start blocking signals. Right? So this will all become apparent, once we kind of get through this. So we need to set our signal counter up first. So we want to count up to 3 signals, and our look back period must match our counting up to. Right? So this is something that's a little different than how the signal counter is normally used. So, and that's because, our signal source, right? Our signal source is always, we're only wanting to block the signals where all the signals are in a row, right? They're all one after another. So there's no gaps, right? There's no empty non-signals in between. So in other words, we're not going to block this one, right? We're only blocking, the signals that occur consecutively, right? Only consecutively. So with the signal counter, our count up to, so we want to count to the third signal in a row, and our look back period also has to be the same so that the signal counter does not account for any gaps, any gaps in between the signals there. All right. And the other thing is, most people like to use the signal counter in digital mode. So with analog, right, if you look here, you see how the signal counter kind of steps up, right? The output gets higher and higher until we get to our third bar, right? So the the output gets lower and lower until we get to the third bar. So, but most people like to set the output to digital, which is, either we did count 3 signals or we did not count 3 signals. So, all right. So there we go. So if we look at our longs, there's our diamond on that third bar, right? So we should probably mark these. Let's mark these. And so we can see where the diamonds are, right? The signal counter, is marking the bars where we want to eliminate the output or eliminate the signals. All right, next we need to invert the output here. We need to invert the output. Let's see here. So I think we can just simply use the output section here to do what we want to do. So, right, so if you read the output there, it says value if counted, right? So in other words, when we get our third signal, right, a third signal is counted, and so we get an output, right? 1, 2, third signal counted, and fourth and fifth signal counted. All right. So we're going to turn that off by setting it to 0. And then we have a value at 0 count. Right? And if we look at this, what's happening? Well, there's no long output. Right? We're missing a long output. And we're missing the short output. So where we do want to see a signal, right? So on these 2 bars, we do want to see a signal. And if you look at BloodHound has a long output. So now, if we grab a AND node, let's grab an AND node, we can connect our signals in, right? So there's our signals. And now if we connect the signal counter in, and now, right, the bars where we want to eliminate the signals, those signals are now gone. And let's see here. There's one other thing that we should do. Oh, actually, no, maybe not. Maybe not. Let me test this here. So let me give this a name here. So we're counting up to 3 signals, right? So let's say if we want to allow 3 signals through, let's test this out here. And actually, yeah, okay. So everything is going to work as I expected. So what I was thinking is I was wondering if we might have to reset the signal counter. Yeah, that was what I was thinking here. Maybe we might have to reset the signal counter. But, well, okay. Yeah, so using the bar direction solver is not going to require using the signal counter, right? This simplistic, kind of, signal source here, the way it works is right? The way it's working is, my bar direction solver, the way it's working is, right, you have to at least get, 2 down bars in a row, but, or, well, 3 down bars in a row, or 4 up, or 3 up bars in a row, right? So you can see that, let's look at this area here, right? So we have a bunch of down bars, and then they reverse to up bars. So there's always going to be this gap, right? There's always going to be, at minimum, a 2-bar gap, as we see here, right? Going from, one, a down signal to an up signal and vice versa, right? There's always going to be this 2-bar gap, right? Because I'm using the bar direction solver, and we need three bars in the same direction. So that means a minimum of a 2-bar gap. And so because we always have this 2-bar gap, that means that the signal counter doesn't need to be reset, because our look back period is so tight, right? Our look back period is so small here. So yeah, actually I'm going to scan through here and see, and just, I guess, double check here. Yeah, so this is kind of like, this is what I was looking for, is this kind of scenario here, right? So here's the bar direction solver, right? So we get a bunch of up bars, and then we get a down bar that interrupts, and then we have to wait for 2 more up bars in a row, and then on the third one we get an output. So so we have at least this, at least a 2-bar gap with no signals, but but with 1 down bar we get 3 bars. So yeah, so I guess with exactly the way Randy kind of, based on the screenshot that I'm seeing here, kind of back engineering this, yeah, I'd say that the signal counter does not need to be reset here. So yeah, keep in mind, this may not work perfectly in all situations. I can't really think of a good scenario off the top of my head, but if your signal source here, so remember, this is going to be your signal logic, right? So there could be a lot more nodes other than just this one bar direction node, right? This would be your system, right? So this one node here represents your trading system, and and then you're just filtering it through the signal counter, to eliminate extra signals that you don't want to see, right? So you're wanting to eliminate all these extra signals that you don't want to see. A more common trade signal set of logic here might generate a long signal sooner. So in other words, we might get a long signal right there, or maybe a long signal shows up, right there, right away, right? Yeah, so maybe maybe these long signals, stop on the down bar, and then they pick back up immediately on the next up bar, right? If there's an up bar right afterwards, maybe the long signals start generating here, and so so that means that there's only 1 bar in between with no signal, right? Only 1 bar in between with no signal. So in that case, the reset would need to be used if that was the situation there. So, but without having the exact logic, I can't really demonstrate, using that signal, that reset, without having, well, actually, no, we can go ahead and I can at least set the reset up here. There we go. So what we would want is to use the reset no signal. Yeah, the reset no signal. And actually, no, you know what? Yeah, you know what? I think we got lucky here. So I think, actually, I think this would work in most situations. You know, again, it all, you know, when you're building, when you're building a system, it always comes down to the details of exactly, what's going on here. Exactly what's, going on with your signals and everything. But I think for the most part, on the resets, this reset no signal, what that means is, it says no signal. So what that means is, let's look at our signal source here, right? So we have a signal, a signal, a signal, and then we have no signal, right? So these 3 bars here have no signal. So this no signal resets the signal counter, right? So those bars with no signal is what's resetting the signal counter. All right, so I think that does it for this question. Yeah, we've covered everything now. So we even covered, resetting the signal counter, just in case for, different types of, signal sources here.